Today's lesson is on inverse functions, and what we're going to do with inverse functions are find them and then find the zeros of a function algebraically. So the first thing that we have to understand is what a one-to-one function is. And a one-to-one function occurs when there is one x for one y. So one input value for one output value. But as you see in the graph on the right, the parabola, there is one input, x sub 1, and then a y, but there is also, when you input x sub 2, the second x, you get the same y. So, what does this mean? It means that it is not one-to-one, because if we test what's called with the horizontal line test, and it passes through more than one point, then it's not one-to-one. So every function has an inverse, but not every inverse is a function. So a function f has an inverse if and only if no horizontal line intersects the graph of f at more than one point, meaning that there is no y more than one time, is what that means. To be one-to-one means one x, one y. There's not another x that points to that y. So how do we do this? How do we find the inverse functions algebraically? It's simply this. You switch x and y, you solve for y, and then you write it in the f inverse notation. Now, we need to understand that this notation means f inverse of x. So f inverse, that's how we write it. I don't know why it's to the -1. Mathematicians couldn't come up with anything better. So how do we do this? How do we solve? Well, first of all, it says find the domain of range of both f and f inverse and find the inverse. Okay, so let's first of all just write this out, 5x minus 7. The domain of f then it's a line, so we know that the domain is -infinity to infinity, and since it's a line, the range is also -infinity to infinity. Now, if you look at the directions, it said we're going to switch x and y and solve for y to find the inverse. So we switch x and y, and then we divide by 5. So y is x plus 7 over 5. So we write f inverse of x is x plus 7 over 5. Now, what is its domain and range? Well, the domain of f inverse is still -infinity to infinity, and the range of f inverse is also -infinity to infinity, because this is nothing more than a line. Okay? So what does this inverse mean? We haven't really talked about that. Well, if I take f of f inverse of x, remember the composite functions, and I plug x plus 7 in for x, what do we end up with? Well, 5's cancel. 7 minus 7 is 0, so we're left with x. What about f inverse of f of x? So we're going to plug 5x minus 7 into this function, the inverse function. Well, wait a minute, that's 0. Those cancel, you get x. So if you find an inverse of a function, the composite, both directions, f of f inverse and f inverse of f of x, is going to equal x. So that equals x, and that equals x. Isn't that cool how they undo each other? Now, we didn't ask that in the question, but I just wanted you to see that that's what an inverse does to a function. Okay, now it's going to get a little bit more difficult. F of x equals x plus 3 over x minus 2. Now, let's find the domain of f. Well, x can't be 2. So negative infinity to 2 union 2 to infinity. Right? Because 2 minus 2 is 0. It can't be 0. Okay, now I'm not going to talk about the range yet, because I'm going to have you use your calculator for that, because that's all we know right now at this time. So we switch x and y if we're going to find the inverse. Now this is a little tricky algebraically, so stay with me. The first thing we want to do is multiply by the denominator to get rid of fractions. Then what do? Well, we got to get our y's together. We can't do that without distributing. Okay? Now, before we can solve for y, we have to get the y's together. So we're going to subtract y and add 2x. Okay? So we subtracted y and we added 2x to each side. Then we can factor out a y. See that? Factor out a y, you get x minus 1. And then we divide by x minus 1. So our inverse is f inverse of x is 2x plus 3 divided by x minus 1. Now, what is the domain of f inverse? Well, x can't be 1, correct? So negative infinity to 1 union 1 to infinity. Now, why did I leave the range open? Well, I would like you to graph on your calculator x plus 3 over x minus 2. And if you do that, you will see, now you got to put those in parentheses, by the way, x plus 3, and then divided by parentheses x minus 2. Got to put both of them in parentheses, zoom 6. And we can see that it looks like the range is cut off at 1. You see that? Well, son of a gun. Looky there. What do you notice? The range of f equals the domain of f inverse. Huh. Well, let's graph 2x plus 3 and find its range. I bet you can guess what it is without doing it. I bet you it doesn't exist at 2. I bet we have a vertical asymptote at 2. And is that the case? Let's see, 2x plus 3 over x minus 1. And I think that is the case. So the range of f inverse is the same as the domain of f. So this is always true then, guys. The domain of f equals the range of f inverse, and the range of f equals the domain of f inverse. So this allows us to find algebraically range, because right now we just have to use our calculator. Okay, next one. F of x equals negative x plus 5, x over 5 plus 2. So we're going to, first of all, find the domain of f. Well, this is a line, so we know it's negative infinity to infinity. And I'm guessing the range is also negative infinity to infinity, but I'll go ahead and write it and just see if it is. Switch x and y. Solve for y. I'm going to multiply by 5. So this will be 5 times x minus 2 equals negative y. So I'm going to divide by negative 1. So y equals negative 5x plus 10. Yep. So f inverse of x is just a line, negative 5x plus 10. And we know that the domain of f inverse is negative infinity to infinity. And the range of f inverse is negative infinity to infinity. Okay, these are fun. Okay, so now let's go ahead and do a problem that is meaningful for domain. and range in inverses. So suppose the number of rental units that are occupied is given by the function d of p equals 200 minus 0.05p, where p is the monthly rental price per unit. Find the inverse, describe the meaning. Okay, so we're going to switch x and y. Because p, this is really y and this is really x. So solve it. You get x minus 200 equals negative 0.05 y divided by negative 0.05. So x minus 200 over negative 0.05. So in this manner, it's d inverse of p equals p minus 200 over negative 0.05. So what does this mean? Well, this means then in the original says, okay, whatever the price is, that's the demand of the rental units that are occupied, depending on the price. On this particular, when we go inverse, when we're talking about the inverse, let's see, then this aspect is the price and this is the demand, because we switched them. We switched x and y. So now d inverse of 40 would mean 40 minus 200 over negative 0.05, because we would use the inverse function. And if we type that in, that'd be what? Negative 160 over negative 0.05, which is nothing more than 160 divided by 0.05, and we end up with 3,200 units that are rented. So 40 then is my price per unit, and this is the number of units that has been rented. Oh, did I say that wrong? Let's see. Oh, this is a tricky one. Let's see. So this is now the price. Oh, sorry. So the price is $3,200. The number of units that have been rented is 40. So we must be renting spaces for Winnebagos or something like that, because it's the opposite. Here we would plug in price. Here we'd plug in price to get the demand or the number of units occupied. Here we plug in the number of units occupied, and this is what the price is, because it's the inverse.